Question 1a. Given the function f of x equals x cubed minus 2x squared minus 23x plus 60, obtain the stationary points and determine their nature. Determine the coordinates of the point of inflection and sketch the graph of the function. You're also going to show the stationary points and the point of inflection on the sketch. Alright, stationary points. What you're going to have to do is find the first derivative of the function, equate them to 0, and solve. The first derivative is 3x to the 3 minus 1, which is 2, multiply by the power, then you reduce the whole power by 1, alright, minus, multiply by the power 2 times 2x, 2 by 2x to the 2 minus 1, which is just to the 1, minus, the power of x here is 1, so you're going to have 1 times negative 23. So it's just 23. X to the, remember it's going to be 1 minus 1, so it's x to the 0. But x to the 0 is 1, so it's like 23 times 1, but you don't even need to write it there. Now 2 times 2 is 4. So this is 4x to the 1. You don't really need this 1 there. So it's minus 4x. Now, at the stationary point, this is equal to 0. So, let's solve this. We have 3x squared minus 4x minus 23. We could use the quadratic formula. Let's use the quadratic formula to do a solution here. X equals negative b. B in this case, if you remember your quadratic equations and solving them, is in the form ax squared plus bx plus c equal 0. Alright? Now, in this case, you have negative b, but b is negative 4, so it's a positive 4 here, plus or minus the square root of b squared is negative 4 squared, which is 16, minus 4 times a times c, which is 4 by 3 times negative 23, all over 2a. A is 3, so it's 2 times 3. What does this give us? 4 plus or minus the square root of 16 minus negative, so it's going to be a plus, and then we multiply these things out. 4 by 3 by 23. What does that give us? 4 by 3 by 23 equal 276. So this is 276 all over 236. So x equals, what is 4 plus 2? Alright, let us just write 4 plus or minus first. So we have 4 plus or minus the square root of all of this over 6. But the square root of what? What we have is 16 plus 276. What does that give us? So 16 plus 276 equal 292. And we're going to have to find the square root of 292, which is 17.088. Alright, so it's 292. So x is going to be plus 4 plus or minus 17.088 over 6. So therefore, what we have is that x equals then we go back to our calculator. It's going to be 4 plus in one case and then 4 minus in the other case. So it's 4 plus, let me just put this in bracket, 4 plus that, and then over 6 equal 3.51. Call it 3.51. So x equals 3.51, and the other value of x now we're going to find is going to be 4 minus this time. So it's going to be 4 minus that, negative 2.18. So it's negative 2.18. So those are the values of x where you have the stationary point. Alright, so here it asks you for the stationary point. Obtain the stationary points. We want to know exactly where the stationary points are. So to obtain exactly where they are, we need the coordinates. So we have x for one of them. We're going to substitute it into the function. So we say f of the 3.51 equal going to be 3.51 cubed minus 2 by 3.51 squared. So it's 3.51 cubed minus 2 times 3.51 squared. Then minus 23 x plus 60 is going to be minus 23 x, which is 3.51 plus 60. So what does that give us? F of 3.51 equals, and then we work it out using our calculator. So here now we have 3.51 cube. Well, there's no cube on this, so I'll just multiply by 3.51 times 3.51. Just multiply 3 of them. Minus, this is going to be 2 times 3.51. Well, we have a square here. Minus 23 by 3.51. Good. Plus 60. Alright, what does that give us? Equal negative 2.13. Negative 2.13. Alright? So, one of the stationary points is located at 3.51. And let me just write it down here. So, one of the stationary points, call it stationary point 1, is at 3.51, comma, negative 2.13. Alright? So, that's the location of one of them. Then, where's the other one? When x is negative 2.18, what we have is f of negative 2.18 is going to be negative 2.18 cube minus 2 times negative 2.18 squared minus 23 by negative 2.18 plus 60. And then we work that out. Alright? So f of negative 2.18 is equal to, let's get our calculator and work it out. So negative 2.18 cube is going to be 2.18 times 2.18 times 2.18 equal. We're going to have this. What is going to be a negative? Because 3 negative multiply going to be a negative, alright? Two of the negatives gives you positive, then the positive times the third negative gives you negative. Alright, so we say minus 2 times negative 2.18 squared is the same as 2.18 squared. So I just write 2.18 squared, right? Minus negative. When you say minus and then 23 times negative, you're going to end up with a plus. So might as well I just write 23 times plus 23 times 2.18, alright? And then plus 60 equal. Oh, that's quite a large number there, right? So let's check again. Negative that minus 2 minus 2 times 2.18 squared plus 23 by this plus 60. So that's what we have. I just want to make sure everything is okay. That's a very large number, not really comfortable to work with. But anyway, if that is the case, then that is just the case. X cubed minus 2 times x squared minus 23x plus 60. So x cubed, yeah, minus 20 minus 2x squared minus 23 times x plus 60. Well, I guess that's what we have to work with. In an extra large number. So back to our calculator, we have negative that minus 2 times that plus 23 by that plus 60. And we get 90, call it 90, just call it 90 since it's such a large number. 90. Alright. Now, here, it means the other stationary point, call it SP2, is at, and you're going to have it at 2 negative 2.18 comma 90. Now, the nature of the stationary points, we're going to find the nature of the stationary point. So we're going to find the second derivative, right? If the second derivative gives us a positive value, then it's a minimum point. Second derivative gives us a negative value, it's a maximum point. But let us see how it goes. We have f prime x being up here, 3x squared minus 4x. The first derivative, f prime x is 3x squared minus 4x. 3x squared minus 4x minus 23. Minus 23. So the second derivative is f double prime x. Differentiate again. So it's 2 times 3. That gives us 6x to the 2 minus 1. Gives us 6x minus. This is going to be 4 when you differentiate it. Now, what happens when you substitute 3.51 in it? So f double prime of 3.51 is going to be 6 times 3.51 minus 4 equals, well, you don't even have to work it out. 6 3s is 18. And whatever that is minus 4, you're going to get a positive value. So, therefore, what it means is that the 3.51 negative 2.13, 3.51 negative 2.13 is a minimum point, alright? And then f double prime of the next one is negative 2.18 of negative 2.18 is going to be 6 times negative 2.18 minus 4. Well, you can see that this value will be negative. It's a negative value. So therefore, the stationary point at negative 2.18 comma, what was it again? 90 is a maximum point, right? But that it is negative. The second derivative gives negative. It is a maximum point. Alright. The next part says determine the coordinates of the point of inflection. But just before we do that, let us get an idea what the curve looks like. Alright. So far, I want to see what this curve might look like. So let's wait on our graph plotter to open, and we're going to put this equation into it. Now remember, when it comes to the coordinates of the point of inflection, you're going to equate the second derivative to 0. Find out what x is and then put y in it to find the coordinate of the point of inflection. Alright? Still loading up. Alright. While we wait on it, let's look at part B. The point of inflection. It's taking a while to load. Seems like it probably load up. Alright, let's clear this part and wait on it a bit. We have to wait on it some more to keep loading up. Now, the coordinate of the point of inflection. The second derivative was 6x minus 4. So at the point of inflection, the second derivative of x, which is 6x minus 4, is equal to 0. What is x in this case? 6x equals 4, so x is going to be 4 over 6, which is what? 24, 2, 26, 3 is 2/3. And then, when x equals to 2/3, f of 2/3 is what? The function was what? X cubed minus 2x squared is going to be x cubed, which is 2/3 cubed minus 2 times 2/3 squared. What else we have there? Minus 23x plus 60. So we have minus 23x. X is 2/3 plus 60, which is, alright, so let's use a calculator to deal with that. 2/3, let's call it 0.667. Alright, so 0.667 cube, which means times, or to get it more accurate, let's just say 2 over 3 equal, and then times 2 over 3 again, a third time, times 2 over 3. That's 2/3 cube. Alright, minus 2 times, open bracket, 2 over 3, close bracket, squared. Alright, minus 23 times, open bracket, 2/3, right, close bracket, plus 60 equal 44.07. Just call it 44. So the point of inflection would be at 2/3 and 44. But anyway, let's plot the graph and see what it would give us. X cube. Let me increase the size of this. So it's x raised to the power of 3 minus 2x squared is minus 2x raised to the power of 2 minus 23x minus 23x plus 60 plus 60. Bam. Alright. So here now, let me make the graph thicker than it is now. Alright. Nice. So, we said that one of the stationary point was at 3.5 negative 2.13 minimum. So 3.5 negative 2.13 minimum point. 3.5 negative. Alright, so let me see. Let's see now. 3.5 negative 3.5. What am I saying? It was located at, when we did this part, 3.5 squared. Oh, let's redo this part here. Where's the calculator? I wonder if I made a mistake here. This is 3.51 by 3.51 by 3.51 gives us 43 point something. Alright. Minus 2 times 3.51 times 3.51, which is 3.51 squared, equal 18 point something, minus 23 times 3.51 equal negative 62 plus 60 equal. Alright, so we have that. Now x cubed minus 2x squared minus 23x plus 60. X cubed minus 2x, this should have been 2x squared minus 23x, is it 23x? X cubed minus 2x squared minus 23x plus 60. Alright, okay. And we look back at the graph. Right, it's look more like it now. I had 2 instead of 3 for it. So let's zoom in a bit. We have a stationary point at 3.51 negative 2.13. So it's 3.51 negative 2.13, and it's a minimum point, right? Said it was minimum. Good. The other point, negative 2.1890. So let's look at what's going on over here. Negative 2.1890. Yeah, negative 2.18, and it went up to 90. All right. 90 point something, but we call it 90. And it's a maximum point. Good. And the point of inflection is 2/3 44. So it would be 2/3 and 44. So 2/3 would be where? 2/3. Alright, it's kind of close to 1. And we have 44. Yeah, it's 2/3. Positive 2/3, 44, which would be at this point here. 2/3, 44, the point of inflection. But remember, if you're sketching, what's going on? Yeah, if you're sketching the graph without the plotter, the graph plotter, you wouldn't use a graph leaf. You know, they say sketch, they didn't say plot. You wouldn't use graph leaf. So what you would have, you have your x-axis and you have your y-axis. Then you would say 3.5 negative 2.13 is a minimum point. So 3.5 negative 2.13 is a minimum point. So you do this. Then the other point here, negative 2.1890 is a maximum point. We have negative 2.18. Remember, they will intersect somewhere here. Negative 2.18 and go all the way up to 90 is a maximum point. And then the thing there, the point of inflection is at 2/3 44. So you say 2/3 right here and 44. So you identify the point of inflection somewhere there. All right. All right. Now 60 is where it would cross when x equals 0. This would be 60. Right? Did they ask for the points where it cut the x-axis? I didn't see them ask for it. Right. They don't give marks for that because they didn't ask for it. They only asked for the original question I saw asked you to show the stationary points and the point of inflection. Alright? So here, if they had asked you for where it cut the x-axis, you'd have to solve this cubic equation, right? And that's not part of the course outline for this course. No, you would have done it in pre-calculus. Sketch the graph of the function and you sketch the graph and so on and so forth. So that's question 1A.